Assalamualaikum warahmatullahi ta'ala wabarakatuh. Today I would like to present about my project. Okay, my project title is the three-phase Y-to-Y connection. I would like to present for the subject EET208 Electrical Power Technology. Okay, my name is Akhmal Danial bin Abdul Rahim. My matrix number 181093052. I from RK23 Campus Kulim. Okay, this is my introduction. Okay, for this project objective is to investigate, analyze the three-phase Y-to-Y electrical system. Next is to evaluate and analyze the active power absorbed by the load by using 2 wattmeter method and the conventional measuring method. Next is to be exposed to regulation and enforcement of electrical system in Malaysia. This is the objective of this project lah. Okay, for the methodology, we have 3 methodology for this project. First is we need to preparing the circuit Y-to-Y connection. We learn about the PSIM software and we apply the 2 wattmeter method. Okay, this is the figure of Y-to-Y connection. This my learning process of PSIM software, and this is the connection of 2 wattmeter method. Okay, next is the flow chart of the project. Okay, this is the first flow chart of the project. It start with the start, and then go to finding the value of line voltage frequency, the reactance, the resistance value, loss, and the load. And then the project will go through by learning the PSIM software, and then I need to construct the Y-to-Y connection circuit in the PSIM software, and then I need to prove by simulating the result from the PSIM, and then I will get the result and the waveform. And next I need to apply the 2 wattmeter method, and also need to prove the simulation, need to run the simulation and get the result and the waveform, and that's the end of this project. Okay, next for my project finding and discussion. The rated voltage of generator, I'll get 33 kV. My matrix number 181093052 as a transmission losses Z load. This is the calculation for the phase voltage. Okay, for the phase voltage, we need to calculate the equation is V phase equal V line per set 3, and then the result will get 19.5 kV for the calculation. Okay, this is the circuit Y-Y connection that I have been create on the PSIM software. Okay, I will run the simulation. We go to the simulation and run the simulation, and then first we need to we want to find the V phase, so we need to select VAN, VBN, and VCN. Okay, add, and we need to click OK. This is the graph for the V phase. Okay, this is the graph for the V phase. Okay, so I click the RMS. This is the value of the RMS. Yes, This is the value for RMS. Okay, from the PC result I get from the compared to the PC result, I get for the result is very similar with my calculation result. For the PC result, I get 19.0525 kV. Okay, next, in this project, I also need to calculate line current. Okay, for method we need to calculate the line current. We use a formula V phase equal V line plus V load. Okay, this is the result for line AA. The calculation will get only the angle will have a difference, the current will be similar. Such example, the value of the line AA current 137.1446 ampere. Okay, next I need to find the I line. Okay, for we need to find the I line, we click A current. The I line is current IAA, current IAB, current IAC. Okay, then we click OK and click RMS. Okay, this is the value for the I line, and then this the value from this emission we compare with the calculation. Okay, compared to the PC result, this is the PC result. I get for the line 1AA, I get 137.51096. It not have a similar result, but it compared to the calculation result, it have a very minimized differentiate between both this result. Okay, next, in this project I also need to calculate load voltage. Okay, for the load voltage, we use formula is load voltage equal to I load multiplied by Z load. Okay, for this I load multiplied by Z load, also we on the calculation we have a similar result but different angle. For A, B and C load, the result we will get 11201.63 63 volt but different angle. Next, find V line. Okay, same goes ABN for the V line, ABN, BCN. Okay, and then also RMS. Okay, this is the value for the V line. Okay, compared to the PC result. Okay, compared to the PC result, I also get 11.209 kV. The result not so difference compared to the calculation. Okay, next is 2-watt meter method. Okay, for the 2-watt meter method, this is the calculation that we've been applied to get the 2-watt meter method. For the 2-watt meter method, for P1, we will get the result is 2147.944 kilowatt, and then for the P2, we will get 2442.406 kilowatt. This is the circuit 2-watt meter method that I've been create on the PC. Okay, I will run the simulation. first we need to find power 1. And in the formula, when we need to find power 1, okay, first we run the simulation first. When we need to find the power 1 voltage, we need to select the voltage and the current. Voltage and the current. Okay, this is for if we want to find power 1. Okay, and then we click the power range, so we will get the value per watt. Okay, and then we need to find power 2. Power 2, ICC and VCB. Okay, power. So this is the power 2. Compare with PSIM result. Okay, this is the result for P1. This is the result for P2. Okay, the result for P1 from the PSIM simulation, I get 2155.2021, and then for P2 I get 2387.008. A bit different compared to the calculation. Okay, next we go to the power factor. This is the formula that I've been applied to get the power factor. Okay, this is the PSIM simulation for the power factor, and from the PSIM simulation I get the power factor is 0.913, and then from the calculation I get the power factor is 0.995. It have a big difference. Okay, next for the discussion. And okay, the discussion about this project is to transform any delta. First is to transform any delta connection into a star equivalent, so that at the for that the overall circuit is in the YY configuration, and that's why we need to run the YY configuration connection and in the PSIM circuit. And then the total, next is the total average power in a balanced 3-phase circuit can be measured by a summonings and the reading of 2 wattmeter connection in 2 different phases of the circuit. Next is measuring the line voltage and the current voltage, the power factor, and the voltage drop percentage in this project. Finally, the discussion about this project is the value of the power factor is fulfilled in the requirement of Malaysian authority standard, which is minimum than 0.85 for voltage level less than 132 kV. Next, we proceed with the conclusion. Okay, for the conclusion in this project, first is that I get is I need to investigate, analyze the 3-phase Y-to-Y electrical system in the context of the transmission and load impedance, currents, voltage, and acceptable voltage drop based on the following BS S7671 or any Malaysian authority standard. Next is I have been exposed to the regulation and the enforcement of electrical system in Malaysia. And finally is this project is also exposed the evaluate and analyze to solving the problem the electrical system in the real situation as an engineer. That's all the conclusion that I have, and that's all my presentation. I hope you all enjoyed with my presentation. That's all. Thank you. Assalamualaikum warahmatullahi wabarakatuh.